Right. Let's see the question number 3. State what is meant by the center of gravity of a body. The center of gravity of a body is, it's a point actually. Center of a gravity. Center of gravity is a point. What does that point do? A point where all the weight of the object acts. For example, if it is a center of mass, you write a point where all the mass of an object is assumed to be acting, right? So where all here, the center of gravity is a point where all the weight of the object acting. Object means here anything it can be, a pen, a pencil, anything. Object is acting. So let's see that B. A uniform square sign with sides of length 0.68 meters is fixed at its corner points A and B to a wall. The sign is also supported by a wire CD, as shown in figure 3.1. So there are the points A and B, and then CD is a wire. There is a 54 Newton tension in the wire. The sign has a weight W and center of gravity at point E. So there is a weight. Weight acts at point E. The sign is held in a vertical plane with side BC horizontal. So like this, the BC is horizontal. The wire is at an angle of 35 degrees to side BC. The tension in the wire is 54 Newton. The force exerted on the sign at B is only in the vertical direction. So the force exerted at B is only in the vertical. So only that direction you have to say at point B. Calculate the vertical component of the tension in the wire. So you need to resolve the tension on the vertical side and then horizontal. So vertical direction. So this is the y-axis. Imagine vertical direction, and this is the x-axis, horizontal direction. Now the let me name T 54 tension as T. So that will be the vertical component will be T sine 35. So that is a 54 sine 35. So 54 sine 35, you can calculate on the calculator, you will get, so T sine 35 is equal to 54 sine 35, that is equal to 31 Newton. If you put on a calculator, you will get 31. So the 31 Newton is a vertical component of the tension. Explain why the force on the sign at B does not have any moment about point A. So there is a point A, and there is a force which is directed that way. Let's name it as a F. So why it does not have any moment? They are saying why. So the moment, what is the formula for moment? Moment is how much force is acting times perpendicular distance from the pivot. So there is a force. Let me draw a line of action here. So line of action means the line elongated at the point of force. So what happened now? So if I draw a line of action, the line of action is passing through the point A, which means the perpendicular distance is zero. There is no perpendicular distance. That's why the moment is also zero. So the reason can be two reasons you can write actually. One is perpendicular distance is zero. Uh, what is the perpendicular distance? So from the line of action to the pivot. Okay, there's a perpendicular distance that is zero. One reason you can write. So perpendicular distance between point and point A, actually point A and line of action. line of action is 0. That is one of the reasons. Another one is you can write line of action is passing through the point A. So the same meaning, but in other word, another way of expression. Okay, by taking moments about, let's move to the I. By taking moments about point A, show that the weight W of the sign is 150 newtons. So let's come back to the diagram again. So this is a thing you need to talk about. You need to see the diagram so many times. So here, this is a point A. Your focus should be on point A now. Okay, how many forces are acting on the signboard? This is a one force, which is a weight downwards, and then the upwards, vertically upwards, which is we just calculated that as a 31 newtons, 31 newtons, and then this one. What is this one? This will be T cos 35 degrees. T cos 35 degrees. Okay. Weight T cos 35, T sin 35, and also F. We just see that there is no moment of F about point A. So forget about it. Now the remaining three forces are there. One is W, T cos 35, T sin 35. The W produces clockwise moments, T cos 35 and then T sin 35 producing anti-clockwise moments. Okay, so the signboard is in equilibrium, which means clockwise moments are equal to anti-clockwise moments. So the clockwise moments, the weight is producing. So the weight times perpendicular distance. Perpendicular distance between A and the force is, see here, this is a point A and then this is a perpendicular distance. So half of the side A, side BC, you can write. So half of 0.68 is how much? 0.34. So W times 0.34. W times 0.34. That is a uh, clockwise moments. And then anti-clockwise, that should be equal to anti-clockwise moments. What are the anti-clockwise moments? The first force is T cos 35 times, that's a force, and then perpendicular distance is 0.68. There's a one force. Another anti-clockwise moment is T sine 35 times 0.68. There's a another anti-clockwise moments. So these are one anti-clockwise moments. This is another anti-clockwise moments, and then they are added up because sum of all anti-clockwise moments. So the W is equal to 54 cos 35 times 0.68 plus this one we just found T sine 35 is 31. We found 31 times 0.68 divided by 0.34, which will give you uh, 150 newtons. If you put it in the calculator, you'll get 150. And then calculate the total vertical force exerted by the wall on the sign at points A and B. So the total vertical force is how much? The weight is 150 Newton downwards, and then the vertical component of the tension, which is 31 Newton. So 150 minus 31, which is equal to 9 and then 119 Newton. That's rounded to be 120 Newtons. Okay, just round off. No big deal. The C. The sign in B is held together by nuts and bolts. One of the nuts falls vertically from the rest through a distance of 4.8 meters to the pavement below. The nut lands on the pavement with a speed of 9.2 meters per second. Determine for the nut falling from the sign to the pavement the ratio change in gravitational potential energy to the final kinetic energy. Of course, it's very easy. That is mgh, which that is change in gravitational potential energy, divided by half m v squared. This is a kinetic energy, final kinetic energy. So the mass is cancelled out. If you see the question also, there is no mass given of the nut. That's why it will be cancelled. And then 9.81, even if it is given also, it will be cancelled. So don't worry with that. 9.81 times the height, which is 4.8, divided by half times v squared. Velocity is 9.2 times 9.2. So if you calculate in the calculator, that will be 1.1. That will be 1.1.